Hello, everybody. Welcome to our lesson. It's lesson 3 today in week 5, Natural Science Grade 8. My name is Arifa Hafaji, and I'm going to take you through to today's lesson. Hope that you're all having a good day. I would like you to all keep your cameras off during the lesson, so please don't use your cameras and keep them on at any time. Okay, so by the end of this lesson, what you need to know is the energy transfer in an electrical system, circuits and current, electricity, and components of a circuit. So to recap yesterday's lesson, what you need to know is that static electricity results from friction, and it's friction between particles with like uh, uh, charges and opposite charges. The like charges repel each other and the opposite charges attract each other. So friction transfers electrons between atoms, and this results in one surface becoming positively charged, and it results in another surface becoming negatively charged. And positive and negative charges attract each other due to a loss or gain of electrons. So friction is also caused through rubbing. Okay, so this was basically static electricity and what caused everything that we discussed in the concept of static electricity, which was on Tuesday and Wednesday. So I'm going to give this to you as homework as well with today's lesson. So we're moving on to the transfer in an electric system. So I'm going to explain basically what transfer of energy means in an electric system. An electric current is a movement of charges in a closed conducting circuit. So you know that you learned in chapter 1 in matter and materials that electrons in an atom are rearranged in the outer space around the central nucleus. So if you look at the diagram here at the bottom, so you see the electrons here are the blue ones. They are rearranged in the outside of the nucleus, and the nucleus are all the atoms that are red. So these electrons are rearranged on the outside. Okay, and then you saw that the electrons were transferred between objects resulting in a charge on the object. Now in metals, the electrons are able to move freely within the metal. So now in this metal, you can see that the electrons, these arrows are basically showing you that the electrons are moving around freely. And electrons are not associated with a particular atom in the metal. Now these electrons that are moving freely here, they're not associated with any particular atom in this metal. So then we say that the electrons in this metal is delocalized. Okay, so we say that the electrons become delocalized because it is moving around freely. So delocalized means that the electrons are free to move throughout the structure. And this, because now it is delocalized, it gives rise to properties such as conductivity. That means that it can conduct electricity. Now, if you look at the diagram here as well, so you'll see the nucleus, like the one where I'm pointing at. Now, you'll see some electrons, they are attached to it in a fixed position. So this means that these electrons cannot move. So the electrons that if you look at the arrow way on the picture, it shows you D electrons are free. So if you look at the electrons that are not touching the red protons, these are the ones that are delocalized. And these are the ones that move around in a battery cell. Okay, and these free electrons that move around in the battery cell, they conduct electricity. So the conducting wire in an electric circuit is made up of metal because metal is a good conductor of electricity. So if we supply it with a source of energy and a complete circuit, then the electrons will move in a general direction through the wire. So now what happens if we attach this battery cell to a copper wire or a conducting wire, conducting metal or anything, then basically what happens is that these delocalized electrons, they no longer move around in random direction like you saw in the other picture. They move around from the negative terminal here to the positive terminal if you look at it in a battery cell. So they're moving in one direction. So just to recap what I said here, so in grade 6 and 7, you basically, let's do a little revision of it. You learned that the electric circuit needs a source of energy. So the source of energy is basically your battery cell. That's the source of energy. And inside your battery cell, it basically looks like this in this picture that I showed you here, with the positive terminal here on this right-hand side. So your cells have both positive and negative terminals. So the one next to where my laser beam is here, this is your negative terminal, and that is your positive terminal. So you can see your delocalized electrons are moving from negative to positive. Okay, now that only happens when you attach a metal conducting wire to the battery cell. Otherwise, it doesn't move like this. It will be all in random direction. So a circuit is a complete pathway for electricity. So a circuit allows your electricity to your current to pass to your bulb, and it gives you electricity. Now the circuit must be closed in order for a device to work. So I'm going to show you pictures on that, how you get an open circuit and a closed circuit, and what makes a bulb start. And we can say that the electric circuit is a closed system which transfers electrical energy. So you get an electric circuit that is open, so that is your switch. So when you put your switch off and you don't have lights in your room, that is an open circuit. But when you put your switch on in your room, that means you're closing the gap, and your light comes on. This means it is a closed system. So a circuit is made up of various components, which we'll look at in more detail. So we're going to look at what the components of a circuit are. So basically, if we look at the diagram, this is what a circuit would look like now in real life. So this is your battery. These here are your conducting wires. This is your bulb. So it's attached to a switch over here. Now this switch, because it's touching this metal and that metal, it's a closed circuit. Okay, so I'm going to go through the questions, and then I'm going to give you a chance to answer it before we actually go through the answers. So if we look at the circuit, have a good look at it over here. And then I'll read through the questions, and while you're looking at it, you can listen to the questions. So what are the parts that make up the system for transferring electrical energy? Do you think this is an open or a closed circuit? And then you must give a reason why you think that. And then which part is providing the source of energy in the circuit? Which part is providing the source of energy? And then what is the conducting material? And what type of energy does the battery have? So you're going to tell me what type of energy. Remember, there's different types of energy. So would anybody like to try? You can raise your hand for question 1. What are the parts that make up the system when we're going to transfer electrical energy? Anybody wants to try? Okay, John. My host will unmute you.
Good
Morning, how are
Good
you?
morning. Fine, and
Good
you?
morning. I'm good, thanks. Okay, your answer?
Okay. My answer is no, I forgot.
No, it's
um,
fine. What are the parts that make up this electrical energy system? Just look at the pictures and you'll know. Like, what is this?
It's a light bulb, but it's the
Okay.
components.
Yes, the component. So we want the component. So the component is one
Yes.
is the light bulb, then the other,
Battery,
okay, your battery, and then,
your circuit line,
okay, and
the switch.
your switch. Excellent. Very well done. So the parts is basically the components. Thank you for your answer. Well done. Okay. So you have another question, John? Okay. So we say in the parts, which are the components, is the battery, the conducting wire, the light bulb, and the switch, which he correctly answered. Does anyone else want to have a chance? So what do you think is a closed or an open circuit? How would you explain a closed or a open circuit? Ratabele, my host will unmute you.
Hello, ma'am. An open circuit is when the bulb can light up, and then the closed circuit, it means that the bulb can light up because of
Okay,
if it's open, then the energy wouldn't pass through the wires.
very good. So if it's open, the energy wouldn't pass through the wires. So an open circuit depends on the switch. And then a closed circuit allows the energy to pass through.
Flow,
Very
yeah.
good. Well done. Well
Thank
done. Okay, so I'm going to give you the answer. So it is closed as the switch is closed, so it's a complete unbroken pathway. So this is a closed circuit because the switch here is closed. So it's an unbroken pathway. Okay, so remember the words, an unbroken pathway. So it's allowing the current to flow from the cell, goes through, and it goes to your battery, to your light bulb. So which part is providing the source of the energy? I'll ask my host to unmute someone. We're going to unmute only one person. Hi. Okay. We must be having some technical difficulty, but when he can, he will unmute you. Okay, please don't feel bad. So which part is providing the source of energy? So the answer would be the battery. So this is the battery. Okay, and what is the conducting material? So the moment my host solves the technical problem, he will unmute you. So please just stay with us. So what is the conducting material? So the conducting material, you can say it loudly in your house, so you know it. I'll hear you, don't worry. Okay, so the conducting material is the wires that are made up of metal. So inside this here, it's covered like with a plastic cover. There's wires inside this plastic cover. And you have to have this rubber that's covering the wires because it protects you from getting shocked. Tariq, let's see if you can get a chance to answer question 5. Okay, no. Okay. So what type of energy does the battery have? So we'll say it has chemical potential energy. So chemical potential energy means that inside the battery, you have the chemical components. And chemical potential energy is the energy stored in chemical bonds of a substance. So inside the battery, like I showed you earlier on in earlier pictures, there were chemical bonds inside the battery. So now when these bonds are broken and the energy is released, we say a chemical reaction takes place. So those free electrons are moving from the negative to the positive, from the negative to the positive, and it is traveling to light up the light bulb. Okay, so another question is, what is this energy transferred to when the circuit is closed and the electrons move through the wire? So what is this energy transfer called? Does anyone know? Nanshlanshla, do you want to try?
Uh,
I can hear you.
Ma'am, I want to ask a question, ma'am. Which, since in a simple circuit, ma'am, which way does the electric current go? Which way does it go, ma'am? Does it go by the positive side or the negative of a
Yes.
battery, ma'am?
Okay, so the electricity is transferring from the positive to the negative. That's correct. Well done for that. So now we're looking at what is this energy transferred to when the cell is closed. So let's see. We say that potential energy is transferred to kinetic energy of electrons. So potential energy is basically stored energy that the object has. So potential energy is energy that's not moving, and it's due to the uh, object's position and the arrangement or state. Okay, so now this potential energy is now transferred. So what is this energy that is transferred? So potential energy is transferred to kinetic energy. So kinetic energy is moving energy. So initially those, when you have the battery, if it's just in your hand, the battery is in a state of potential energy. Okay. But now when we apply the wires to when we connect the wires to the battery, and we make the circuit, this potential energy is now transferred to kinetic energy. And kinetic energy is moving energy. So the electrons start moving. Okay, so that's a definition for potential energy for you. So potential energy is the energy stored within an object due to the object's position and arrangement or state. Okay, I'll ask my host to unmute someone. I think they have a question.
Hi, ma'am.
Hi.
May I answer number 7?
Okay.
So, ma'am, I think the output of the system is light energy.
Oh, excellent. Well done. Very,
Thank you,
very
ma'am.
good. Well done. So the output of this system is light energy. Can also be heat because the light is giving off heat. But the answer is the bulb lights up, so it is light energy. That's the correct answer. Okay, so now what I have here in the diagram below are the components of the of a circuit. So a complete circuit is a complete conducting pathway of electricity. So know this, a complete circuit is a complete conducting pathway of electricity. It goes from one terminal of cell along the conducting material through a device and back to the cell, which is the battery. Okay, now we're going to look at this. We have a wire. The wire looks like this. And then we have a resistor. I'll take questions just now, not right now. A resistor and a circuit that you're going to draw, because you must know that in your exam they can give you a circuit, and then they'll have all these components in the circuit, and they're going to ask you to label it. Or they can even ask you, for example, draw a circuit with 2 light bulbs and 1 resistor and 2 cells and a switch. So they'll just give you the instructions and you'll have to draw and label it. So you need to know how to use it you need to know the symbols to use when you're going to draw it. So this is a resistor. You draw a resistor like this. Now tomorrow's lesson is on resistors, and I'll explain what a resistor is tomorrow. I'll just give you a brief description just now, but we'll go in depth to it tomorrow. And then, not tomorrow, sorry, tomorrow is a public holiday, so it will be Monday. So light bulb, this is your symbol for a light bulb. That's how you will draw it. Then we have a cell. This is how you draw your cell. But remember, you have a big line here and a small line here. So this shows you from positive to negative. The big line and the small line. Don't forget that. And these lines here are basically your wire. Okay. Then your battery. Now the difference between a battery and a cell is that a cell is single and a battery is a combination of cells. Like you see here, there's 2. Okay, so a battery is a combination of cells. And then we have a switch. And here you can see the switch is open because you have one dot here and another dot here. You have a line, and the line shows you that the switch is open. So I'm just going to get maybe two people because I do need to finish the lesson within a time frame. So I'm going to ask my host to unmute two people, and randomly I'm going to ask you what's the definition of, let's say, a switch. Anybody
Um,
want? Okay, wait, not a switch, of a light bulb.
Hi, ma'am.
ma'am,
Hi.
Ma'am, I just want to know if a battery has two cells, how does one cell look in real life? If you put it in a circuit.
So basically, you have a cell, right? And it's
Yes,
simple.
ma'am.
It's very simple. It's not as concentrated because you get different types of batteries, right? Now, basically, we refer to batteries, but they actually, the correct terminology is a cell.
Okay.
So we refer to it as battery, but the correct terminology of use of it is a cell. So a battery
Okay.
is actually a combination of many cells.
Okay.
Okay,
Okay. Okay. Thank you, ma'am.
um,
okay. You're
ma'am,
welcome.
ma'am, I would
Yes.
like to right here at number 7. I would like to go up at there. Someone answered that it's a light energy, right? So so it's because of it travels from the battery. That's my reason. It travels from the battery to the wires and goes through to the to the light bulb. That's when it gives heat energy and light energy. And
Yeah.
ma'am, sorry for interrupting you, ma'am.
No, it's fine.
Ma'am, you can ask a question.
Are you going to tell me what's the function of a light bulb?
Yes, ma'am. A function of a light bulb, it gives light energy and also gives heat energy. So light energy is for us to see and heat energy to keep us warm.
Okay, and you can tell your little brother or sister hello. Thank you so much for the answer. So I'm going to put the answers up for you. The wire. The wire allows current to pass through it. Now, a resistor is used to reduce current flow. So remember, we're going to do this on Monday, and I'm going to go in depth to it. We're going to reduce current flow. So this is a resistor. So the light bulb converts electrical energy into heat and light. So light bulb, it converts that flow of current, which is the electrical energy, and it converts it into heat and light. Then we have a cell is a single unit, and it provides electrical energy. And we have a battery. It's a collection of cells that provides electrical energy. And then we have our switch. So our switch is, it allows current to flow, and it can be open or slow. So the switch allows the current to flow, and it can be open or closed. So in this diagram, we're showing a open switch. So if we take this line here and we join it to this black dot here, then the switch would be closed. Okay, so now I'm going to move on, and I'm going to show you the components here in how they look in real life. So now remember that I told you the main difference between a cell, for exam purposes, is a cell is a single unit and a battery is a combination of cells, but this is how they refer to the symbol of a cell. But in ordinary life, what we call a cell is actually a battery. Okay, this is what it is. So, and then you get different types. So battery provides the purpose, electrical energy. So in a test, what they can give you is they can give you all these components, and then they can mix all these purposes up, and then they'll give you a line, they'll give you a line here, and they'll tell you match column A with the correct answer in column B, and write the answer in column C. So then you'll need to mix and match to know which is the right answer. And you'll say like 1 For example, this is not the right answer, but let's say this is A, B, C, or D, then you'll say 1D here. But 1D is not the correct answer because I have it in order here for you. But that's how they set it up in your test if they're going to ask you the purposes and components. So then we have a power supply. This is your symbol. And the purpose of a power supply is to alternative of, it's an alternative, sorry, used for using cells. So instead of using a cell or a battery, you use a power supply. And then that's how it looks. Okay, then I'll take your question just now, Ratabele. Then we have a wire. So this is how your wire, the symbol for it, and this is how it looks in real life, and it allows the current to travel. Then we have a light bulb here. This is the symbol. This is how it looks in real life here, and it converts electrical energy into heat and light. Then we have a motor. So this is the symbol for a motor, but we're not going to get into that in this lesson. This is the real life, how it looks like, and it converts electrical energy into movement energy. So the motor converts electrical energy into movement energy. So it allows a device to move, right? Like you have remote control cars and stuff. So you would have to have a motor. Okay, and then you have a buzzer. So this is the symbol for a buzzer, and then it converts electrical energy into sound energy. So this is how your buzzer will normally look, and then your switch. So in for drawing a diagram, your symbol for a switch is this, and in real life it looks like this, and it allows the circuit to be open or closed. So a resistor, it can either look like the one that I'm pointing my laser on, or this one that I showed you initially before. Most of the time we use the second picture that I have my laser on. So the purpose of a laser is the components that opposes or inhibits electrical energy. But I sent it very easily for you before, that it prevents energy from flowing through. It inhibits electric energy, the current from flowing through. And then you have a variable resistor. Also, we'll go through that in tomorrow's lesson. So the resistor whose resistance can be adjusted to higher or lower. So you can control the speed of the electric current through the variable resistor. Okay, Ratabela, do you still want to ask your question, or can I move on to the next slide? If you still want to ask it, then you can raise your hand.
Ma'am, I would like to ask, the motor and the buzzer, why is it important in a circuit?
Because we're just doing a simple circuit right now. We're not going to be doing, I will explain it to you as we progress into other lessons. I don't want to confuse you by telling you a lot. I just want to make you familiar with the terms of what they are, and then I'll explain it to you in later lessons. Is that okay?
Yes, ma'am, it's okay.
Okay, thank you. So normally when we learn from easy and we go to difficult, and then it makes things easier. Because when initially, remember in previous lessons, I put what you needed to know, and then some of you felt I was going too fast. But as I progressed through the lesson, I explained everything that you needed to know, and it became easier for you to understand. Okay. Okay, so here we have a closed system, right? We have a closed system. It has one cell. It has two light bulbs, and you can see that the switch is closed. So this is how you would draw your system when they ask you in class or in exam. And then we're going to draw an open circuit with two cells, two light bulbs, and a switch. And this is how it would look. So it doesn't always have to be the same. You can put it anywhere, your light bulbs anywhere, as long as you fulfill the requirements of what they asked you. So here is a closed circuit, and here is a open circuit. Okay. So now, Andy, you have a question?
Hi,
Hi,
ma'am.
I can
Ma'am,
hear
I just
you.
want to ask, are we going to do parallel circuits also or not?
Are we going to do a bit of?
Parallel circuits.
Yes, but not in this lesson. So we're going to do
Okay.
series and parallel circuits in this next week.
Okay.
Okay.
All right. Thank you, ma'am.
Okay, no problem. Anyone else? My host will unmute if anyone else wants to ask. Hi,
Hello.
I can hear you.
Ma'am, can I ask you a question?
Yes, no problem.
My question is there a difference between the symbol of a light that is on and the light that is off?
No, it doesn't show you. The only thing that you would know is through the switch. If
Oh,
the switch is open, then you know that the light bulb would be off. And if the switch is closed, then the light bulb should be on. But the symbol is the same. There's no difference. Okay.
okay.
Okay. No problem. Thank you. So now, John, you have a question? Okay. So now, if we look
Good
at
morning,
this
ma'am.
morning,
Ma'am, may I please ask, since I have to do an amusement park for a project, are circuit boards useful?
circuit boards are very useful because it helps you to understand um, the concept of energy flow and how to actually draw it. So in every grade they ask, I mean, I know in most grades they ask you to draw circuits, and in some grades they ask you to actually make it in different ways. So it teaches you that concept so you can apply it in real life, because some people would like to become electricians, or you want to become, you use electricity to make things. So you need to learn how to make it and do it. Okay. But
Yes,
I'm
ma'am. Yes, ma'am. So, ma'am,
okay.
also, is it possible that when you do your project, um, like for example, for an amusement park, and then you take out your light bulb, then you only use the switch and the batteries, your amusement park gonna still work?
No, you have to, what I'll give you my email address, and then I can give you some guidelines. I'll give it to you at the end of the lesson, and then you can
Okay, ma'am.
show me and I'll show you how to set it up. Okay? Would that be okay?
Yes, ma'am. No
Okay,
problem,
no
ma'am.
problem. Okay, thank you. We have 1, 2, 3, 4. So here there's 4 cells and 1 light bulb, and they don't have a switch. Okay, so now look at the diagram carefully and you identify the bulbs, the switches, and the cells in the circuit. So that is it. Okay, so now look at this one. So someone asked me earlier on about series and parallel. So this is when it's one below the other, it's parallel. And if it's all next to each other, it's a series. But we'll do that next week, not today. Okay, so we're going to identify the number of bulbs and switches in this cell. Okay, I'll ask my host to unmute one person. I can hear you.
Hello.
Hi.
Ma'am,
Yes.
if one switch is on and one switch is off, will the circuit still operate properly, or
Okay.
there'll not be a transfer of energy?
Okay. So let's look at this diagram that I have here. I put at the bottom. So if this circuit here was closed, so the energy would light up this light bulb here. This is a parallel. But if this circuit was open, even though this is lighted up and this is open, this won't light up. Okay,
Okay,
so
ma'am.
that's for later lessons, not for this lesson. Okay, but that's a very good question. Well done for thinking of that.
Yes, ma'am.
So there's one, okay, 5. So there's 1, 2, 3 cells. There's 1, 2, 3 batteries, and there's 2 switches here. And you have your conducting wire. So 3 cells, 3 bulbs, and 2 switches. So can anybody identify what's wrong with this circuit? Okay, my host will unmute only one person. What's wrong with this circuit?
Ma'am, the thing that there's something wrong there is because there's no switch. If there's no switch, the circuit can't just operate. It will just be on the whole time.
Okay, if you don't have a switch in a circuit, it will still work. The circuit is just to control the flow of energy, but something else is wrong. What's wrong?
Okay.
Okay, I'll give you a clue, and then you can tell me what's wrong with it. Sorry about
The cells are actually, the battery is actually joined together, but there's a line between the small lines there.
Okay, very good. So the cells are not arranged properly. So if this is a positive and that's a negative, you can't have a negative next to a negative. So it has to be basically your positive and your negative. So it should actually be arranged like this. Okay.
Ma'am, I also have a question.
Yes.
About at the previous slide, at the previous circuit that you were showing us, ma'am, is it normal to use one switch at 2 bulbs?
Yes, you can use one switch for 2 bulbs. It's no problem.
Oh, okay.
Okay, the bulbs just make it. The bulbs will just make it brighter. Okay.
Yes, ma'am.
Okay. Thank you. Right. So now we say one cell is in the wrong position as 2 negative terminals are facing each other. So you saw here the 2 negative terminals are facing each other. Instead of a negative terminal of one cell being connected to a positive terminal of the next cell. So you have to have a positive and then your negative and then the positive and the negative. You can't have it like this. Okay. So then this is the correct way it should be represented, except here I put a switch and then this shows you it's open. So your cells should be arranged this way. Okay. So now, why do you think it is useful? Let me, I need to just move this. Why do you think that it is useful to have a switch in a circuit? It is to provide an easy way of opening or closing the circuit and therefore controlling the electric circuit. And then why are conducting wires made out of metal? The reason for that is because it is a good conductor of electricity. So I'm going to explain the meaning of cells to you. Okay, so an electrical cell are the source of energy of the circuit. Where does the energy come from? So remember the pictures that I showed you earlier on? So inside the cell, there's a number of chemicals, and this chemical store potential energy. So when a cell is in a complete circuit, the chemicals react with each other. Okay, and as a result, the electrons are given potential energy and they start moving through the circuit. So remember I said they start moving through the circuit in one direction. Okay, they don't move in any direction. So when the electrons move, they both they have potential energy and kinetic energy. And the electric circuit is the movement of electrons through the conducting wire. So kinetic energy is the movement of the electrons through the conducting wire. Okay, and this kinetic energy would be electric current. So batteries come in different sizes, and different sized batteries provide different amounts of energy in a circuit. So you can see at the picture, all these batteries, they come in different sizes, and then they give you different outputs as well. So the types of cells you would use in toys, torches, and other small appliances range from AAA, AA, C, D. So you would know what the sizes are by these alphabets here. And 9 volts. So these alphabets here, they usually have a rating of 1,5 volts. But the larger cells have a larger capacity. So the bigger the battery, the bigger the number of volts it can contain. So this means that batteries will last longer and they won't go flat. Okay. So also in some batteries, it can be small, but it can be, remember we use the word dense, density, that means that there's lots of chemicals inside it. So it can have a bigger, a higher rating. So, and then it would last longer. That's why you have even the small batteries here that last longer because it has more chemicals in it. So it's more dense. So a cell goes flat when it's no longer able to supply energy through its chemical reactions. So when it's no longer, then we say that your battery has died. But the correct way is to say that your battery or your cell, the correct terminology is your cell went flat. So we buy cells in a shop, and they are usually referred to as batteries. Okay, I'm going to just move this here to the top. Okay, we can, this can be a bit confusing because a battery is really 2 or more cells connected together. So when we refer to a battery in a circuit, then you draw 2 or more cells connected together. Okay, so the concept of cells and batteries is actually a bit confusing. So we need to know that batteries, when they are flat, you shouldn't be throwing them into the dustbin. They need to be recycled. And it must be recycled, I'll take questions just now, because it contains toxic chemicals which will leak into the soil and it will contaminate the environment. And different batteries contain different substances, such as lead acid batteries used in motor cars. And this is particularly damaging to the environment. So we need to be sustainable and we need to dispose of batteries in its proper way. And then some ways to save our environment is to, when you're buying batteries, buy batteries that have a longer lifespan. Make sure that you use your electricity, all your resources efficiently. That means you should switch off and unplug devices that you're not using. Then don't steal energy and connect energy from poles through unauthorized way. Then you choose batteries that have low toxicity. That means that it's not toxic. Then recycle and reuse them because you can get rechargeable batteries. Okay, and enable round trip efficiency. That means buy batteries that would give you long life, long lasting, and are efficient. And make sure that you have you use clean energy. So that means that instead of always using electricity in terms of burning coal, we can use renewable energy like wind energy, thermal energy, but that's for a different lesson. Okay, I'm going to take one question. Okay, so our summary is, hi. Hello. Okay, an electric circuit is a system of transferring electrical energy. And for a circuit to function, there must be a complete, unbroken pathway for electrons to flow. A source of energy, which is the cell or cells, are loaded and you have a light bulb and a resistor, which I'll explain on Monday. So we use symbols to represent components of an electric circuit so that everyone can interpret the diagram, and I showed you what the symbols are. So here's helpful links for you. You can visit this website. It shows you and it demonstrates how you make a simple circuit. And this website here also shows you how to draw an electric circuit. So the guy that had the project for the amusement park, visit these websites. It would give you a good idea as to what you would need to do and for your project. Okay, so our next lesson is on resistors and the effects of electric currents. You're welcome to ask me your questions on Monday in our next lesson. This is your homework. So remember that diagram that I did on static electricity? You're going to draw one and you're going to fill in these missing blanks. Okay, and then I want you to draw and label an electric circuit with 2 cells, 2 light bulbs, and 1 switch. I will take questions, not today now, on Monday. You can write them down and keep them and I'll answer them. So you're going to draw and label an electric circuit with 2 cells, 2 light bulbs, and 1 switch. Okay, and that's my email. It's been a pleasure tutoring you today. I hope you benefited from this lesson, and I'll see you again on Monday. Have a lovely weekend. Goodbye.